Hello and welcome everyone. Today we are going to look at the greed kata. So my name is Brendan, welcome to DevChatter. I just wanted to get you guys up to speed. That's what we're planning on coding today. I called it a kata, but I'm not really going to treat it as one. I think we're more going to do a programming exercise today. The difference there is that in a programming exercise, we're just going to work on this as a group. Shout out any ideas, anything you want to do. We're going to do it in .NET Core because, new hotness and all that, and why not? We're going to pop open XUnit for our testing framework, and we're going to program this together. So if there's anything you want to do along the way, any questions you have, shout them out, let me know, and we'll get started. So the place that I want to start is talking to you a little bit about what the greed kata actually is. I'm going to pull up a set of instructions. This is a set that another developer and I have been using for quite a few years, this set of rules. We've built up PDFs and done this with different groups in the past as, say, a learning routine so they can figure out how to do the dice game. He put together a nice catalog of different katas that we've worked on in the past. They're out on GitHub, so if you notice any problems with them, you can adjust them there, send in a pull request, anything you like. But this is the basic thing that I want to do today. So, greed is a pretty simple game. The way it works is you roll dice, and then you take those dice, you save some of them to calculate a score, you continue rolling. So that's a little bit complicated for what we're planning on doing today. So as just our little programming exercise, what we're going to do instead is just calculate the total score, not counting any re-rolls or anything like that. So what we're going to do is we're going to have this player roll 5 6-sided dice, and we're going to figure out how many points they can earn based on that. And the way that it works is there are a set of rules that determine how many points certain amounts of dice can be worth. So what we get is we're going to have this person roll a set of dice. If they get a 1, that's worth 100 points. If they get a 5, that's worth 50 points. If they had 2 1s, for example, that would be worth 200 points. 2 5s would be worth 100 points. So these rules can be applied multiple times as long as the set of dice that you have contain multiple matching sets. Any given die can only be scored once. So I'll give you an example. So 3 1s are worth 1,000 points. So what that means is that if we rolled 5 1s, for example, that would be worth 1,200 points. 4 1s and a 50, for example, right here, is worth 1,150. That's 1,000 points for the 1s, and then 100 points. Hey, thanks for following. To Joe Phillips. So what we end up with is these sets of rules follow a little bit of a pattern. So the first set is that we have 2s, 3s, 4s, 5s, and 6s all follow the 100 times the number that you rolled. So if you roll a 5, it's 500 points. If you roll a 6, it's 600 points. The exception is the 1s, where they're going to be worth 1,000 points for rolling them. So 1s are very good in this game. It's also possible, if you didn't roll any scoring dice, so no 1s, no 5s, you'll notice this set's worth 0, because there are no 1s, no 5s, and nothing do we have a 3 of a kind on. So let's go ahead and get started. I think the easiest thing we can do is start off with our 0 case. And for that, I want to go in here and make an XUnit project. So I'm going to open up .NET Core, get myself an XUnit project in .NET Core, and I'm just going to call it unit tests because we're just doing Hey, welcome, Janisku7. Hope I'm saying that right. So we're going to set that up. If you're not familiar with XUnit and you're used to, say, mstest or NUnit, this works pretty much the same. The main difference that you'll notice, we don't have a class attribute on this for a test fixture or a test class, and our test methods are not called test methods or tests, they're called facts. Sometimes they're called theories, and we'll see what the difference between those is. So to start this off, what we want to do is go with a pretty simple test. Now I'm planning on making Greed a program that I can run, but I probably also want to have a class library that we can test it against. But for now, since we're just doing a programming exercise, I'm going to toss this class inside of the Greed console app itself, and I'm going to go ahead and call this class the GreedScore. Shout out if you guys want me to do something in here differently than how I'm doing it. So unit test 1 I don't really like, so I'm going to call this, I'm going to put it in a folder first. So one thing I like doing when I'm making tests is I like to have a folder for any class I'm going to be testing, so it keeps it nice and organized. The next thing I do is try to get it so that these namespaces are very clear, and it's clear what I'm doing. So I think that it makes the most sense to call this method that we're going to call, say, calculate score. Maybe? So calculate score is not bad. I kind of get what it's supposed to be doing. So I'm going to rename that file. So now we have a file here, we have GreedScore, and this needs to have a public int. I guess our scores are always integers. Calculate score. And this is going to need to take in something. For now, we're going to go ahead and just throw a not implemented exception. And then in our test, we're going to say return 0 given no scoring dice. Okay, so whenever I'm writing tests, I like to start with the simplest case I can think of, which in this case is we're calculating someone's score and they did not actually get any points. So right now this is going to fail because I throw a not implemented exception in my code. Oh, I didn't call it. So we are able to run these, and I am going to add my dependency. I don't actually need to, my tools will add it in for me if I just try to use this, but most of you probably aren't running the same tool set I am. So I'm going to grab my GreedScorer. Nope. GreedScore, new one of these, and I will calculate my score, which is going to get me a result, and I'm going to assert that that result is 0. Actually, I am going to add a dependency to a NuGet package first. So I'm going to grab Fluent Assertions, which is a package I'm a big fan of, and I don't think it's going to require the .NET framework. Okay, well, that's a lot more stuff than I wanted it to pull in, but I guess I won't complain too much. It's just a programming exercise. Okay, so calculate score, and then I am going to say should be 0. So that's my assert statement. I like this style a lot better than just doing assert.r equal this value, because it's really clear. It says, hey, this result that I got should be this value, and that's nice and easy to read, and sets up the expectation that the should be, I'm saying this should be So this is my expected, and this is the actual value I got. It's nice and clear. I don't have to remember which one's which, whether it's the first or the second parameter, which some testing frameworks do make you remember which one's which. Okay, so once I've got that, then I can see, I create one of these, do that, run that. Now this should fail nicely with my not implemented exception. And cross your fingers. Hey, there we go. Not implemented. Good. So once we've got this, I can easily just go in. So whenever you're doing any kind of kata or programming exercise or anything like that, I recommend that you try to do things more deliberately. And in this case, the discipline that I'm talking about here is that in test-driven development, you want to take things in small steps. Now, the reason you want to do this is because you don't want to make any big leaps and potentially break the code. So the idea is that through slow, methodical steps, you can develop something. There will be points where you're going to need to take a leap, but you want to do those leaps only because it was the right time and not just because you know that you can get to some certain design that you want to do. So I recommend that you take short steps in your testing when you are doing a kata or a programming exercise. And the reason why is none of us are as disciplined as we'd like to be all the time. I make an effort to be as disciplined as I can, but I know that I'm going to take some shortcuts here and there when I'm writing code. And I want to make sure that I'm deciding which shortcuts I'm taking because it's a programming exercise, and which ones I want to make sure I do right because when I'm really writing this code in the future, I want to make sure that I don't, get lazy. So take small steps like this. So obviously the return 0 is not really the result I want, but it will pass this test. And so that keeps things simple. So, all right, cool. So that lets me focus on a couple of other things, because first off, I'm just starting my testing suite, so I don't have any kind of reuse or structure set up, so it's very simple right now. So now I want to say return 100 given single one. Okay, so right now my calculate score is not taking in any dice, so I didn't really do anything. I just said, given no scoring dice. Well, I didn't even pass any in. So what I'm going to do is I am going to let it receive some other values. So yeah, I know the values are only ever going to be 1 through 6, so I don't need an int, but trust me, it's just going to be easier if we do. I'm not worried about the memory on this. So let's do an int array of dice rolled. And actually, to make it easy, let's make it a params int array. Now, if you've never seen params before, it's going to let us do a neat trick. I'll go ahead and show you. So I could go ahead and, whoops, wrong one. I could say new array and insert in the values, right? And then that's acceptable for my array of integers. But because I used params, I can actually work a little bit differently. I can say 1, 2, 3, 4, 6, 2. How many dice was I saying I was going to roll? We are going to roll, that is 1, 2, 3, 4, 5. 5 dice. Okay. So we're rolling 5 dice. So this is my set they give me that is an example where we get 0. But alternately, I'm going to put that same set down here, but change out that 2 for a 1. Hey, welcome, Staker. Thank you for following. So now that we've got this, I should be able to run this code and watch it. Well, actually, it's going to pass because I didn't change that. But let's go ahead and change that. We're expecting it to be 100 now, but it won't be, obviously. So we returned back 0, so clearly that wasn't going to work. So the real cool thing for anybody that just hasn't seen params before is I was able to either declare an array and pass it in, or just start putting in values. That's what params tells C# to do, is just accept a list of parameters and treat that as an array. So what I'm going to do is just say if dice rolled contains, and I'm going to say a die that equals 1. Again, keeping super simple here. Oh, right, because it was just doing that one. That's hilarious. Then we're going to return 100. So again, easiest thing that works. Easiest thing that works. And the reason why we're doing the easiest thing is because we just want to get to the next test. This lets us build up a suite of a handful of tests so we can write our real code. So now that we've got this one going, let's say, you know what? I'm actually going to do 15. So I was going to do 2 100s, and then we'd get the idea that we count the 100s multiple times, but I actually think, well, yeah, we'll do it that way. We'll say 200, given 2 1s. So I'm just going to swap those out. So I have basically the same test. I'm expecting to get back 200. I'm passing in 2 1s and 3 dice that don't really matter. So it should be pretty easy. Clearly we're expecting this one to fail, because we didn't actually write the code to handle that yet. And it fails. So let's go ahead and take a look. So here's where we have to figure out how we want to handle this. So there are a lot of ways, and this is sort of where we start going down different paths. So let's go ahead and say dice roll dot so I want to grab the dice and say let's get all of our 1s. So this is rolled 1s. And then I can say for each rolled 1, so total score. So I could have backed up and pulled total score out on its own. Probably should have for the test, but it's not a big leap. That's a pretty small one. Let's see if I manage to break everything. Okay, so nice easy case. We are through that. We have a loop now that counts our 1s. So I don't mind how that's working. I have this one that I don't really care about right now, which is a little weird, but I don't think I'm going to toss it just yet. You might be saying, like, why'd you do it this way? You know, because I could just do a count on that and say pull the value out with link. So if you like, I guess I could do that. So I can count those, and then so the count of those, and then we will just multiply that by 100. So again, remember we have green tests, so there's no reason not to just go ahead and refactor right now. So I'll show that code again in a second. I just want to make sure I'm green first. I like to do that before I even stop and talk about things so that I don't lose what I was doing. Okay, so all I did here, for those of you that didn't catch it, I have this array of integers that have some values in it. And what I'm doing is I'm going to say for every 1 that's in that set, I am going to multiply. I'm going to count them up. So let's say there's 2 1s in there. I'm going to do a count of how many of those numbers in my array equal 1. And then I'm going to multiply that by 100. And then that'll just be added into my total and returned. Now I understand right now I could just straight return that value because we're not doing any others, but I'm not going to get rid of the progress of having extracted a total score value variable there. Okay, so the next thing I want to do, let's add the 1s and the 5s, but actually I should say combined. But before I do that, I kind of want to change how this test works. So I mentioned when we started this that XUnit has both facts as well as theories. So I'm going to go ahead and put in a theory here. And a theory is where we're going to use inline data. So I'm going to take inline data, and what I'm going to do is pass in our set of numbers that we're going to provide to this collection. So I'm going to put that in there, and then I am going to make this a params int array rolled dice. Okay, and then I'm going to pass in the other set also. So I now have 2 examples in here. There is the single one and the double one. We're going to change this test name to return single ones scores given only single ones. So return single one score. Calculate score should return. I'm going to say correct score given single ones. Okay. So before I get to the params, I need to have expected score. Now here's where this is going to get a little tricky, because I am actually not sure how it's going to handle that. Whether it's going to figure out that the first value is that or not, but we're about to find out. Okay, so this should have switched us to the tests we were doing before, but just built a little differently. Okay, so it looks like that probably passed. So just to be sure, it's always important to make sure that your tests can fail. So I'm just going to change the value to a failing one, just to make sure it's running as I expect it to. Okay, so expected it to be 100, but it got 200. So that means that it really is running that code, and it really is doing what I think it's doing. So at this point, we now handle the single ones scoring the way we expect it to. I'm going to move my head so you guys can see that also. There we go. Hey. Okay. So what we have here is a pretty good step for this. I'm going to do the same thing, but now for 50s instead of 1s. Because they also score the same way, pretty much. So, and I'm just going to change out these 1s for 5s, because that is a pretty simple change. So, whoops, return correct score given single ones, correct score given single fives. Okay, so keep in mind that because these tests are the same, I could have used the same inline data, but the only reason I did it this way is because I like having these two separately named tests. In my results, they're going to show up a little differently, and so I think that is a nice way of handling things. If you want them all to be one test, name it the way you like it and do it that way. So there is no right and wrong with any of this. So, okay. So we ran these tests, which yes, I know I could have written one, but again, it was pretty easy to just copy that, so made it nice and simple. So by the same token, the easiest thing I can do to make this work, I could do the if thing again and say if it contains a 5, but no, there's no reason to do that. The easiest thing to do in this case is to just copy the previous code that did basically the same thing. So there we go. So we have all of our passing tests, so it looks like it runs the way I expect. So the next thing I want to check, so we know that 1s work, we know that 5s work, but what we haven't seen is 1s and 5s working together. So I'm going to go ahead and set that up so that we can see that, yeah, they work together. Based on how the code works, I think we know that it's going to work right. So let's say single 1s and 5s. So let's add a 1. That'll make that 150. And then let's add 2 1s down here, which will make this 300. Okay. Let's see if that works. Okay, good. I like seeing green. Sorry about that, guys. Got distracted for a second there. Okay. So the next thing that we want to look at, so we can handle these singles just fine. The simple case, if we're looking at our next rules, is we need to handle some of these triples. So we handle the singles, but we don't handle any of the triples. So the first bit of complexity is how do we handle the 5s? Because we're already scoring based on the 5s. Why don't we start simpler and go with 2s? So I am going to go ahead and start with 2s. So my theory is that 200 points should be the amount that we get given. And I'm going to front load the values that we care about here, just because it's a little easier to read if they're up in the front. So 3 2s is going to be 200 points. So we said the number on the die times 100. Let's see. Turn 200 given triple 2s. You know what, I'm going to write the word 2. Okay, so return that given triple 2s. Okay. So this is another pretty simple one. But right now it's not going to work, which is fine. We don't expect it to. Okay. So when we get this back, we end up with 0 as we expect. But we can do something about this. We can easily say total score plus equals dice rolled dot count, and then, yeah, I'm going to do the cheater thing right here. You're going to love this. So we're going to say how did I end up with length there? I guess that's what I get for what? I think it's trying to help me and saying that's an array. Arrays use length, not count. Well, thanks, buddy. Okay, so this count, if it's greater than 3, greater than or equal to 3, so I'm just going to say greater than 2, then I want to add on 200. Otherwise, I'm going to add on 0. No, I'm not going to keep the code this way. I know you're all getting terrified because I'm writing link. It's just an easy way to get that result. Okay. Now, I might keep it there someday, it might end up as link, I'm not sure yet, but that's an easy way to just get my total. If you don't know how this worked, I used both a ternary and link here. So I got the count of the number of 2s that are in my array, and I said if I've got more than 2 of them, so 3, 4, or 5 of them, then I want to get, 200 or 0. And actually, if I want to do this fair, I should say this. I should say the count equals 3, and it's going to pass. And then I should do another test where I have quad 2s. So my fourth 2 should still be 200 points. And in this case, we're going to skip it because I looked for exactly 2. So see, that one failed. So now I can go back here and say, no. We can say greater than or equal to 3. So, and then it's going to work just fine. Anybody have any other ideas for anything? There's a couple of things I want to clean up. Shout out if anything in here is bugging you guys. Just go ahead and type it in chat and we can fix it up. So the one thing that I'm noticing here is as I write this, I will tell everybody that your test code is just as important as other code, which means not that you want to test your tests, because unit testing your unit tests that unit test your unit tests starts to get bad. However, we do want to keep it clean, make sure that we're reusing things. So you probably noticed that I have a lot of repetition here. I do pretty much the same thing in every one of these tests. So that tells me that basically the only thing I have separate test methods for is just to get these clear names. So what I'm going to do is go ahead and make a method. No, I'm not going to make a method because my keyboard shortcut's not going to work. So apparently I don't get to make a method, guys. That's fine. Refactor extract method. Yeah, I'm just gonna rename it. Okay, good. It did what I wanted to. So I'm going to make a test expected score method that each one of these is really just going to do. Because that's really just named sets of data. There's been no change in any of these, with the exception of that first one, which is still a fact instead of a theory. But that's fine. Because this is my rolled set of dice, and my expected score is 0. So that makes that pretty easy. There are other ways I could extract that out, but it's not bad as is. I don't mind it. Okay. So we made sure that we handle the 4 of a kind and the 3 of a kind on 200. But we didn't do that for any of the other numbers. So I kind of feel like we should handle one of these other numbers since we're at this point. However, I want to handle the case where we have ones and triples at the same time and make sure that that works. Now, I'm pretty sure as written that this test is going to pass already, but I want to make sure that it can fail. So, given triple twos with 5. So, we're going to give it a single 5, and we're going to say that the score should be 50. Now, first off, it's going to pass, but I want to make it fail because I need to confirm that it can. So what I'm going to do here is go ahead and make all these fail. So all the ones that have 5s for 50 are going to fail, but I specifically just want to make sure that mine does. Okay, because that turned red, I know that this test is failing, which means that it can fail if we don't have that. It's very important to make sure that your test can fail, because it is very easy to write a test and realize later on, oh, I didn't set up my test right. And when you're finding out about it later, that's because your test didn't protect you from something. Okay, so that seems to still be working. Let's go ahead and take a look at a triple of something else. So let's try 3 3s. Okay. There we go. So that's 4 3s, and that is 3 3s. And we're expecting these to be, whoops, 300. Turn 300 given triple 3s. Alright, pretty easy. And thanks to our tests all being nicely structured now and having that code reuse, we don't have any extra work to make that happen. So it should just be our triple 3s failing. It is. Okay. So now we're getting into a bit of complexity in that we don't handle the 300 yet. So I can put this in here. I can just put in the 3 and the 300, and I know that this is going to work. However, this is starting to get a little because our code doesn't look that great. We do know that it's working. We've got some tests. What here seems to do what we expect it to do. So I'm not a big fan of how this is going, but I'm not going to complain too much about it either. I could write methods for these that say named them. So I could extract this and say score single ones, passing in dice rolled, create a method for it, and I can return that value. So then I could do the same thing for scoring single 5s. Now remember, I can start getting away with this because I have a test suite that can make sure that I don't lose any of this functionality. So I can just say score single 5s, change this to the 5, change that to 50, and now this does, whoops, same thing as that line. So now I've got score single 1s and score single 5s, and I should be able to do this. So that's a little clearer than just having 3 little lambda link statements in there. I should say link statements with a selector using a lambda, but that's not bad. I could clearly replace this with a for loop or any other kind of whatever I want at any point because it's hidden inside this little method. Now there's a reason I'm doing these methods, and you're gonna see what it is later. What I'm trying to build here is I'm setting up for a specific pattern that I think that is going to work nicely here. You'll see what it is in a bit. It's called the rules engine pattern, and I think it's going to apply nicely. And the reason I suspect that is because, I mean, obviously I know it, but but the way that you can suspect it is you start getting this, you get this list of rules. So when you actually have a list of rules that's in your description of the work that you need, there's a good chance that you can apply a rules engine to it. Because it's pretty clear that for any one of these, when you receive a set of dice, the rule is either going to be applicable or it's not going to be applicable. And one way or the other, you can either apply it or not. And that's basically how a rules engine works. So the next thing that I want to do here is make some kind of method to handle the triples. So I'd like to do it all at once. I haven't written the pieces for 400, 500, and 600 yet. And I definitely don't want to do the 1000 yet because the ones are so weird. But I think I'm going to write that. So I want to change from having this 200 and this 300 to be correct score again, given simple triple. Hey, welcome. Thanks for following LNG Grinds. So what we're going to do is change to this structure, and the reason I want to do given a simple triple means that I don't want to handle, I'm not going to test the 5s or the 1s here because they're complicated because they get scored twice, sorta, kinda. Now the die itself doesn't, but if you have 4 1s, then one of them gets scored separately from the others. So, and 1s are just clearly different. So I'm going to take this inline data from that one, bring it down here, and just treat these all as the same thing. So, because right now, because all of our tests are the same, the actual running of the test is actually just that inline data line, and the rest is just names. That's what all these methods become. So it lets us get away with that little move that I did there, and handles it pretty nicely. So you can see our tests are still passing. We're still doing those cases. So I'm going to add the cases really quickly for the 400 and the 500, no, the 400 and the 600. So these will be the 400. These will be the 600, which means that these are going to be 4s. Actually, let's do this. 4, 4, 4. This one needs to be a quad 4. This one already has a 6 in it, so we're going to need to fix that. So let's say 6, 6, 6, and then 6 and 2. And then on that top one, we'll change that to a 3. Okay, so we now have triple 2s, triple 3s, triple 4s, triple 6s, and then we have quad 2s, quad 3s, quad 4s, and quad 6s. And all of our expected values are what we think they should be. So I'm going to go ahead and run these tests and take a look at what we get. Okay, good. We know that it's going to fail because we didn't do 4 and 600 yet. So I'm going to go ahead and put those in really quickly, and then I'm going to make the change. So that's the 4, that's the 6. And yes, I know this is not the best just yet, but bear with me. It's still not that complicated. So if you know how count works, you can look at this and it's still pretty easy. Okay. Now we're expecting those to go green, as long as I didn't typo anything. Nope, we're good. So we handle all the simple cases. The next case I want to handle, before we pull these out, because I do want to have a method that handles this set, which I guess I could do. So I will do that. We're going to go ahead and say private int score simple triple. Now, there's a couple of ways that we could do this. I could do the simple triple like this, where I return dice rolled times that value, and we're going to take a look at what that does. So this number 2 right here, I'm going to pull that out. So pip count. So for those of you that don't know, on a D6, the dots actually do have a name. They're actually called pips. So congratulations, domain knowledge. If you didn't know that, those are called pips. So the pip count. So instead here, I'm going to say, instead of 200, I'm going to say pip count times 100. So this should handle the 2s, 3s, 4s, and 6s nicely. And in order to make that work, I am going to put that in there. And then 2, 3, 4, 6. Delete those. And at the beginning, I need to pass in dice rolled. There we go. Okay. So now I should score a simple triple for 2, 3, 4, and 6. And so now you'll see that even though I am still using this link and these lambda expressions, it's still not very complicated because I've hidden all that away. And if you look just at this value, you can see it's not super crazy. If I wanted, I can write it like this, for example. And actually, I can even simplify that ternary that we've got there so that I don't do that either. But I see no reason not to use the link. It's pretty simple. If it looks complicated to anybody, if a member of my team, commented about it and said, hey, I have trouble reading that, then obviously I would just switch to a for loop because there's no reason not to. It's going to run the same way. That's, realistically all that's happening behind the scenes is that the link is going to make it so it loops over that for me. So, okay, we now have this running and it works for all the different types. And we've gotten rid of a lot of our repeated code. So we now just call this triple method, passing in that. Pretty easy. There is still a case that we're not handling. And that case, so we did this up here. We said that we wanted to handle triple 2s, but also have a 50. Let's up this one a little bit, make it a little more complicated. Let's handle the case where we have all 5s. So first off, 3 5s we said are going to be 5 times 100, so 500, plus the 2 5s, so we're ending up with 600 as the total. So for anyone that joined us late, we're doing the Greed kata. This is a dice scoring kata. Hey, welcome fossils, thanks for following. So we want to handle a complicated case where we're going to return both the value from getting triple 5s, but also any additional 5s or 1s that we put in here. So I'm going to say, again, just return correct score, which I know is kind of meaningless, but at the same time, it's that, when you're reading it, it's going to inline that value, so you'll be able to see what it is anyway. And you'll see that when I bring up the Test Explorer again. So we'll say given single scoring dice with triple 5s. So we're expecting 600, but actually I'm going to go ahead and put in another one here. I'm going to do the 550 from only having 4 5s. And I also want to put in 3 5s and a 1, which is going to be 600. And then I also want to put in 3 5s and 2 1s, which will be 700, because 500 plus 100 and 100, and then 500 and 100, and then 550 and 550 and 50. Okay, so that should work nicely. We'll see what we get. Okay, good. we didn't do our 500s yet, so looks like we expected to have 550, but we only had 200. And the reason here is that it counted all those 50s as single dice. So you might realize what we're about to run into here. So I'm going to handle this the naive way, which is going to be wrong, by the way. You'll see in a moment. If I just go in here and I try to add in the 5, we're still going to break. Because what I did was I just told it, hey, handle the 5s the same way, so do a 500 for it. So that's not quite going to work. So now we're over on them. We added too much. And the reason is that we didn't tell it not to count the 5s a second time. So there are some ways that we can do this. So we pass in our array to this object when we're working here. So we could modify this set of dice. We could modify this array and remove the used dice, for example. Which, again, little crazy, but bear with me here. We need to in some way indicate that we've already used a die. Now, maybe. So there are multiple ways to do this. One option is we can remove dice from this collection and say, hey, we already used it. We could mark which dice we've used and exclude them from the set using link before we do any calculations with them. So, for example, I could keep a set of used dice, for example. I could say list of int and say, you know, like used dice and track that. Alternately, when I do, I could handle just triple 5s, for example. So I could say score triple 5s. I don't need to pass in the pip count for triple 5s because I know that it's triple 5s. So I could do this. So I could say triple 5s score. Actually, I'm going to make this different. So we're going to say if, and I'm going to steal this. So let's take it, we're going to do it this way, I think. Instead of returning back the used dice, which I do like the idea of returning back the used dice, it seems like a big leap right now. So we're going to say greater than or equal to 3. Dice rolled count, dice equals 5, greater than or equal to 3. Helps if I don't put in a space there. Then we're going to say that we have a triple. So this is 5s rolled count. Okay, so we're going to do that. We're going to grab the count of the 5s that are rolled, and we are going to say, so we only want to give them any points if we got in here. If we didn't get to this, we're going to return back a 0, right? So I'm going to handle the simple case again, where we're going to say if we got in here, then I want to return 500, right? Because we said 5s, you know, whatever the pimp count is multiplied by 100, we're going to return that. So this is the simple case not using the ternary. It's the same code that we have down here, just that I did it slightly differently. I used my if statement here. So this should fail for the same reason. I'm going to go ahead and run our tests again. So these failed for pretty much the same reason as before. So you can see the totals are about what they used to be. This one did 500 plus another 200, so it clearly totaled them all together again. So what we need to do, if we're going to do this, is say return 500. So this is our cheater way. Wait until you see this one. This is going to be good. we're going to say 5's rolled count minus so we could just total that, but I don't really want to. 5's rolled count. Actually, this will be easier to understand this way. So I'm going to call it excess 5's equals 5's rolled count minus 3. So we said it was greater than or equal to 3 is our total, which means this is either going to, this has to be 0 because we couldn't have gotten in here if it was less than that. So excess 5's is 0 or more. So we're going to say subtract this times 50. So basically what I'm going to do here is I'm going to say, actually, no, I want to do it by 3, right? I want to always subtract 3. Yeah, I think I want to subtract. So see, this is what I mean. It gets a little complicated sometimes. So this would be minus 150. Let's go ahead and run it. Our tests are going to tell us whether we got this right. That's what I mean, is it's complicated sometimes figuring out what you need to do here. So see, we don't have it quite right. Oh, I'm not running it. Duh. Good job, dude. Okay. I think we got it though. Let's go ahead, and I'm going to remove that 3 times 50 that we had in there in case it passes. Okay, it passed. So let's go ahead and get rid of that just to confirm that it can fail. So we're going to run these again, make sure that they fail for the reason we expect, because it turns out we weren't really running the code. Again, reason why you want to look for the failure, because as it turns out, we weren't really running the code we thought we were running. Okay, let's put it back. Run this again, and it should be passing. We saw it pass once, so should be good. Okay, so that works out nicely. We've got that running. So this is terrifying. Alright, so I'm going to put that comment in there right now because that really does scare me, having that in there. But hey, it worked. It was not the worst thing I've ever done. I can admit that. We've all written some scary code sometimes, because that is quite the hard-coded thing there. Now, at least I separated it, because I could have just said, you know, like, oh yeah, return 350, and someone would be like, 350? What? Where's 350 coming from? And it's like, at least I made clear that, hey, I'm removing 3 times 50. Okay. So we handle that. It handled both the 1's and the 5's. So we know that worked. Next thing that I want to take a look at is return correct score given single scoring dice with triple 1's. So return correct score given, I just want to say given triple 1's numbers. I'm just going to handle all the triple 1's here. Hey! Welcome, Calvin A. Allen, person I've never heard of before. Thank you for following. So I'm going to put that in there. So that is a pretty simple case. I'm going to add in a 1 there. I'm going to add in a 5 here, and I'm going to add in 2 1's there. So in this case, we're expecting 1200. Right here, we are expecting 1050. And right here, this is 3 1's is 1000 plus another 100, so 1100. And the top one is just straight 1000. Whoops. Alright, that should be right. I'm going to go ahead and run these. We'll take a look. There's no way this code works just yet, but that's fine. Okay, so you'll see it didn't do our triple ones. We didn't think it would. So like we did with fives, we're going to do a triple ones the same way. So I'm going to say handle triple ones. I'm going to move this to the first one just so it's clear to anybody reading this that we handle the ones, the twos, the threes, the fours, the fives, and the sixes. Making a method for it. And then doing pretty much the same thing I did here. Except I'm not rolling these. Ones rolled count. Helps if I type correctly. Dice rolled, we're looking for the ones this time. And so now instead of subtracting that, we're going to subtract 300. So, because we know if we got in here we had at least 3 dice that were ones, which means we added an extra 100 already. Yeah, I know it's knowledge of the other rule, but that's fine. We're not really using a rules engine yet. So let's go ahead and just run this and see what we get. Okay, so everything's passing. So that is good. So hey, I think we're actually pretty much done here. I don't like the state of everything, but let's take a look. Do we handle all of those cases? We handle single ones, single fives, triple twos, triple threes. Yep, we handle all of those cases, and this code works. So we could stop right here and call this good. We have a lot of tests on this. We know this thing works. And it's not all that complicated. But I think there are some nicer things we can do, and I talked a little bit about doing a rules engine. So why the heck not do one? So let's take a look. So at this point, we're in an okay state. Our system is easy. I mean, this is push worthy right here, not just a commit. We could push this code out and it'd be fine. However, I want to make this nicer because first off, a couple of things. These scare me. I want to get rid of it. I don't mind the fact that we were able to handle all the triples with these, and I don't mind that this is using link. None of that bothers me much at all. Even this looks pretty easy. It's pretty clear, hey, we're just, adding in all these different types of scores and doing that. As we add new rules, it's going to get a little complicated, and you'll notice something else I had to do. We're not following a lot of good design principles here because of one thing that we're doing, and it really is this comment I put in this OMG, this scares me. That's the problem. So what we're doing is we have set up a situation where we're not really following the open-close principle much at all. And the reason why is that as we add in new rules, which I happen to know that there are new rules, it lists them right here under the extra credit. So if we start adding in these extra credit rules, we're going to run into the problem of these rules are going to need to know more about each other. Because what we effectively did when we wrote this little subtraction here is we put in the knowledge that the single ones was a thing. So what I could have done is I could have done this. I could have said, subtract the single ones, but the problem I was going to run into is I do need to add some of them. So it's almost like I need to subtract the single ones without that dice there, and then it starts getting really weird because then this method's calling other scoring methods, and that's just not going to get pretty. So I don't want to go that route. What I want to do instead is start having these methods tell me what they did so that I can handle that better. So here's what I'm going to do. I am going to in some way get back the dice used. So right now I have this int that I'm passing back. And it's okay. But I think I want to have an int array that I pass back also. So what I'm going to do is go ahead and yank these out like this. So remember, I've got tests on this. I'm just going to mess with triple ones right now. So I'm going to say that this is the triple ones result. Okay? So once I have that, there's a couple of things that I need to do. I need to add this to the total. So total score plus equals triple ones result. And I don't want to say, so unless I get item 1, item 2, I don't want to say that. I want to call it maybe value. So let's call this value. Okay, so there's value. And then the other one, or maybe score, I don't know. Not sure on that one yet. And then the next thing I want to do is remove the dice. So I want to indicate that these have been used and spent. Maybe I should do it all in the method. Let's do it inside the method instead. I'm not liking the direction we're going here. I hope you're not liking this direction either. So I could get away with using a value tuple here, but I think it's just going to get ugly. Until we have a rules engine and we're just applying the rule, I think it's going to get a little messy. So, well, actually, you know, I'm still going to do it. So, that's really hilarious that it pulled it out that way. So I'm going to go ahead and call this the triple ones result. And then we're going to dot value that thing, which maybe I'm going to call that score. I don't know yet. So in this case, we're going to return back 0, comma, and then just an empty set, because we didn't actually have any in here. In this one, we're not going to do any of this complexity anymore. We are just going to pass back a new array of 1, 1, 1. So that is the set of dice that we used. Whoops, let me close that. Okay. So now I have returned back the set of dice that we used. So I could remove them. Now I'm going to keep this one a little bit separate just because it's doing some new things. So I want to make sure that we're handling it separately. Okay, so we're returning back this and using it in an interesting way. I'm going to call that dice used still. So once we've used the dice, we need to remove them from this set. So we're going to remove used dice. Not 100% on how I like this, but we're going to try it because, you know, we're developers and we try things. Actually, can I do this? Will it? Will that work? Actually, I think this will work out there. Because I can change the reference then. Whoops. And use dice is these ones. And then I'm going to to-array it. Okay, so the reason I couldn't do it within the method is because we were going to pass a reference to the method, and I could in place remove them. That's a good question. Dice rolled, remove. Yeah, see, I don't have it because it's not a list, because I did an array. But this will work fine. I could change to a list, but hey, this code's working as is, so I'm not too worried about it. So once I've changed that set, we'll accept, remove, process it. Yeah, so it's going to find matching integers and remove them, I think. All right, time to cross fingers, guys. Time to cross fingers. And see if this sucker works. Because I don't have a lot of confidence. Okay, good. Whew! Alright, so I think what happened, so looking at this result, we expected calculate score to be 1100, and we only got back 1000. And the reason is that I think our accept removed all instances of the ones, because that had one in there. So that clearly is not going to work. Yeah, because it found multiple instances and removed every instance of the one, despite the fact that I gave it back a collection of 3 ones. So we need a new way to do this. So here's what we're going to do. We're going to break everything. Yep. You heard me right. We're going to break everything. Okay. So, instead of doing it this way, we are going to get a list of integers called dice rolled. These didn't really need arrays. These just needed IEnumerables of ints. So we're going to get simpler here on all these. Okay. So now, instead of doing this, so we still need to remove the dice that we used. So the way I want to do this is I want to say dice rolled and then remove 1 for each item that's in there. So I want to say triple ones result dot dice used. So I essentially want to do an each, and the way I'm going to do that, I think, is by doing a select and ignoring the result. So a select will let me run code for each one of these. So and I think this is complaining because I don't use the result. I'm not sure what this is going to do, to be honest. We'll find out. Maybe it'll work. But it should reduce the number of 3s in there. Okay, so now we're running into the problem that I used arrays here. So all I need to do is come down here and to-array this, or to-list this. So we're going to take my array, convert it into a list, and it's fine. And so you'll notice because I had the code reuse, I was actually only calling that method from one place instead of having to go through 20 methods and change that value. So very nice to be able to do that. Saves quite a bit there. So our tests succeed except for the ones that have the ones in them. So we expected it to be 1,000, but it was 1,300. So it looks like it counted all my ones again. So let's go take a look at that code and see what happens. So we're going to come up here. Let's go ahead and debug this. So specifically, we just want to debug the one that failed. And I mean, one that failed is 4 that failed. It's almost like the category that failed. So you guys can't see the command line, but it doesn't really matter. Okay. So the result we got back is a value of 1,000, and our dice used is 111. So then for each die that was used, select, we're going to use dice rolled and attempt a removal. And I'm assuming that didn't really remove them. Yeah. So see, it kept them all. So that did not do what we thought it was going to do. So let's go ahead and stop that. So instead of this, we're going to do triple ones result dot dice used. Hit count die used? I don't know. That's tough. That's the... Then we're going to say dice rolled remove. And then we're going to say the die used. And that should work, I would think. Don't know why it didn't work in my select. Maybe it's because Link, was like, oh, you didn't really do anything. Yeah. Okay. Why didn't that let me get away with it? Can I... What? Will you... Huh. Well, either way. Works fine like this, and this isn't too complicated. So, clearly I don't want to do this for each thing, but I could. I could update these values each time. What happens if I try to method this thing? Can it figure it out? I'm going to refactor, extract a method. Do thing. I don't want to think about what I'm doing just yet. Okay, so that applied total score. I don't want that to apply total score first off. Return back total score. Yeah, I just want to return this value, and I want to add that. So I don't need to take in total score either. So dice rolled and triple ones. So I pass those in, I take that value, and down here I can remove them, and I think it works. We'll find out, because that is a reference to that collection, so it should be able to access the same one. And it does. Okay. So because this list, we actually just have a reference, it's the same one as out here. So we just have a pointer to the same one, so any modification we make to it inside here is the same one we do out there. So consequently, what that means is we could do this removal in here instead. So I might do that instead, and switch this back for now to just returning back the int, which I know I'm going back and forth on this, guys. I'm just torn on which way we should go. So we called it do thing for now. Dice rolled, and then I'm going to do 1, 2, 3. So I'm going to have this thing just taken a params. So you remember the params int array from earlier. We're going to call that dice used, which means that's going to be there as dice used, die used, remove die used, and this is a static void. Okay, so it takes in the collection, removes the ones from there, and does that. Okay, so now when we do our we don't do our thing out here anymore. We now do this again. So we're back to our old way of just adding in the total score, except now our score triple ones removes the dice that it's not using anymore. Can that be an iList? It can be. Okay. So I need to have the remove method, which means I need to be using an iList instead of an IEnumerable, because the IEnumerable interface doesn't include a remove method, but iList does. So I've adjusted to that. Now when I run this, let's see if we're still green. Okay, we are. Good, good, good. Woohoo! Alright, so do thing. Now part of the reason I called it do thing is because I wasn't really sure what it was going to do at first. So we're going to call it remove unused dice. And it's really just hiding the fact that we're doing a for each loop. It's a little nicer. Oh, not unused. Remove used dice. Used dice. Okay. So we can do that, which means down here we can do the same thing with the fives. So in here we used 3 5s. So I no longer need to do the scary subtraction thing. Now what I have done is this. I have made order matter. So you're going to see in a second when I run this. I'm going to go ahead and let it run first, make sure it's all green. And it is, so we're still passing, our code still works. But watch what we've done. So I have these up here. If I were to take our scoring of the triple ones and the triple fives and move them down to the bottom, you will see that it now fails, because I now made it important that we score the triples first. So order now matters on these rules, see? Which isn't the worst thing, but it is something we have to consider now. The next thing that we can do is I want to remove the triples here as well, just because it feels now like, since we're doing this, I should start actually keeping track of which dice we've used, because I know, based on the greed rules, that we're only allowed to have one matching. We're only allowed to use a die in any given rule. We can't use it in all the rules. So once it's been used, that die is spent. We've gotten our score out of it, and that's pretty central to the game. So I'm not expecting the extra credit to change that. If it does, I'm willing to take the refactor on that. So let's see. So score single ones, score single triple. So on the triple, we did this kind of ugly thing here. So we're going to call this the triple score. But actually, we're going to make this an if statement. So we're going to go back to the more complicated approach that we liked originally. So pip count times 100. And if we didn't, then we're going to return 0. That's if we didn't have any triples. So if we had a triple, return it back. And I feel pretty comfortable in doing that little refactoring that we did right there, because I have a suite of tests around it to make sure that I'm not messing everything up. Okay, so everything's green. So I'm pretty sure this is the same code, just rewritten to not have the ternary anymore. We're still doing the link with the lambda for matching the pip count. But now I can remove our used dice. So instead of 5 here, I just pass in the pip count 3 times, which has a cool effect. I don't need the 5 one anymore. Now I'm going to let this go ahead and continue passing before I get rid of it here, because I shouldn't need it, because that was the big difference between the 5, was that it was important that I do that. But realistically, I should do it for all of them. So I don't need 5s anymore as its own special thing. In fact, that makes me then think I should just do all the triples first and then add in the singles at the end. So now we've written things a little nicer, so we now score the 1s, 2, 3, 4, 5s, and 6s, and then do the singles for the 1s and the 5s. I like that a lot better. I hope you guys do too. We're still not all that simple yet, and we don't have our rules yet. And again, at this point, as I mentioned, we could have pushed a while ago, we could stop. So if we're out of time, we have other code to move on to, we can. We don't need to keep doing any of this, but this just makes for a little fun exercise we can do. So if we take a look at this, there are some other rules we could look at. So you'll notice here that we're going to get extra credit for 4s of a kind and 5s of a kind, which are definitely going to change some things. But I am going to suggest that we take a look at some of these rules that I was talking about. So here's why I like the rule engine. Whenever you do it, you get to make this interface. It's really fun. It has the best name. The interface is called iRule, and I do, and so will you as soon as you write a rule engine. So you just say iRule, works really nicely, and then congratulations, you're an awesome person. So, wonder if you got any of my joke there. So, in order to do the rule engine, there's a couple of things that we want to do. I want to make an isApplicable method that probably takes in a set of dice. I'm not 100% yet. So, in a rule engine, you always take in some state object and say, I guess you don't have to, but you check to see, does my rule currently apply? Do I apply right now? And if so, take my action that I perform. So we're starting off with iRule. We might decide that this really is getting very specific to greed, and we might call it an GreedScore rule or something like that. But this is going to let us encapsulate some of this code into its own classes. So it'll be a little nice. So let's take a look. So isApplicable, and then let's say we'll say apply rule. This will take an iList of int. Yep, add that reference. These are the dice rolled. And then the other thing, do we need to pass anything else for this one? No. isApplicable is going to be the same parameter. So we don't even necessarily need the isApplicable. We could just return back 0 if it's not. So we'll start there. It's a little simpler. So we have apply rule. So a simple rule that we could do would be a single die scoring rule. So let's go ahead and make a derived type called a single die scoring rule. Okay, so this clearly is my 1s and my 5s. So I'm going to start with this. So now we're saying times some value, so we need the pip count and the number, because I want to apply the, I know I want to use this for both the 1s and the 5s. So return dice rolled count times that. I need to include link. Right? That's what you're complaining about? Using system.link. Stop complaining. Thank you. Okay. So this works for the 1s. So I'm going to go ahead and create it right now just to replace for the 1s. And I'm going to do it in a pretty simple way. For now, I am just going to say new one of these and then dot apply the rule given the dice rolled. Right? And then that's going to work out the way I expect it to, I think. So, whoop, not there, right here. I'm going to go ahead and run the tests again. And hey, that worked. Okay, so this is a nice, easy way to change into, so adding the rules is one of the more complicated pieces. So this is where you start taking a leap, and I mentioned at the beginning that you want to take small steps, but at some point you might have to take a leap, and we sort of hit that here. If we do want to change, if we're thinking, yeah, we can use a rule engine here, and we're going to want to use it as we bring in more things, this is the way to do it. So, the single die scoring rule now needs a little bit of complexity to work for both the 1s and the 5s. So it needs a couple of things. So first thing it needs is to be able to set what the pip count is. So the pip count for this one, we are going to initialize from the constructor and make it read-only. And then I'm going to make this a parameter called pip count. And so now you'll look out here, you'll notice it pulled the 1 all the way out for me using my refactoring tool. So I extracted that number as a field, so it was declared up here. I assigned it from the constructor, and I pulled that out so it's a parameter. Now I'm going to do the same thing with this 100, which is the value per die. So I'm going to call this underscore value per die. I'm also going to initialize from the constructor and make it read-only. So my single die scoring rule has these numbers, and then I want to pass this in as a parameter as well. So the value per die is 100. So now I can do this same rule, but for 5s and 50, and I can get rid of that rule. So now, when I run this, it should do what I expect. And there we go. So that works nicely. So I now have the single die scoring rule. So now what I can do is I can, you know, I'm just going to put this in its own file for now. I'm going to put that one in its own file. We're going to come back in here, and we're going to make another rule. So we're going to create another die rule here that's going to be called simple triple die rule. So we'll make another public class for this one. And in this one, I think you can guess where I'm going here. I'm going to go back and grab the triple one, which is right here. So, oh, not score triple ones. I want to score simple triple, which is this one here. I roll score simple triple. Okay. So the piece I want right now is I really want to have the default methods on an interface to do this quick removal here. But instead, in order to get that right away, I'm going to make a base rule. So I'm going to make die using rule. We're going to make it a protected static method and have these inherit from it for now, which I don't really like. What I want to have is a default method on my I rule. That sounds much better. So I'm going to make this abstract because I don't want anybody actually creating one of these. So this is my base class. So I'm actually just going to put base on it so that everybody gets that that's abstract. Oh, is that... what's it? I'm not sure what it's wanting to rename there, but I'm not going to let it do any renaming on that, because I don't want it to. Go get in your own file, you piece of junk. What a piece of junk. Alright. Still not going to give me system link. I'm going to add it myself again then. Alright. So we have link again. We called it pip count. Oh, I don't have pip count in here yet, but I will. So what I'm going to do is I'm going to go grab this rule and bring this in here. Now we don't have a value per die concept. I guess we have a multiplier. So we could use multiplier to do it, but I think that's complicated to say like times 100 and then times 1,000 for the ones. That gets kind of weird. So we also could just have the resulting value in there, and that would be fine also. So we're saying pip count times 100. We're going to remove the dice where the value is the pip count and return back 0. So this rule should work now. So we'll find out. I'm going to break the ones. That's fine, because I didn't leave that value in there. I'll bring it back, just temporarily, just so we're not broken. But we're going to get rid of simple triple. Okay, so what I'm going to do here is I'm going to use my new simple triple die rule. We're going to pass in dice rolled, and then we're going to pass in our number. We're going to say apply rule, and actually this is where we're going to pass in dice rolled. I'm a liar. I did that backwards. So we're going to remove that from here. So 3, 4, 5, and 6. Okay. So feel free to shout out if I do anything that you don't know how I did the thing I did, and I will show you what buttons I'm pressing and what things I'm doing to make it work. Okay. So my tests are still passing. So here's what we've changed to. Instead of calling individual methods, we now have this set of rules that we're applying. So I'm just creating objects to do this, but we can now make a collection of these and set it up and add new ones, remove new ones. So say like we have a situation where someone wants to play a game of Greed and decide which rule set they are using. Say they're doing house rules or something like that. They can choose which rules we apply, and so we can just fill up a collection with the rules that are appropriate to the game being played. So the last one that I need to do to have all of these set up as rules is to do the this is the triple ones die or scoring rule. Scoring rule. I'm going to change that name on the other one. Make another I rule. Scoring rule. So those are scoring rules. This is a base die using rule. This is a scoring rule. Okay. And actually, that makes sense then that these are going to be I scoring rule. Not sure what it just did, but let's hope it still builds after that. Okay. I think that might work. We'll see. I can steal this code. Passed in that. I need to add system link because every time I extract out the object, it takes the reference with it, which is nice. However, I do kind of want to, occasionally have it back when I'm working on these things, but okay. Now I should be able to get rid of these. New. This is triple ones scoring rule. Fly rule. Dice rolled. And that one I don't have to pass in the 1 because it already knows how it works. Okay. So now for the change that I said we could make. So this works, and I've essentially just pulled all the code out of this class and made it live somewhere else. But I didn't really do much more than that. I haven't really done anything that improves this all that much. So let's go ahead and add all these rules at the top. So yeah, I know this is going to get a little messy right here because I was just sort of chopping, but it's fine. It's fine. We can fix it. Okay. And one there and one there. Okay. So clearly, if you notice based on my adding commas, you know that I am about to make a new list of I scoring rule. And to that list, I am going to add these items. Whoops. I don't want to put it on that one. I want to make a field. So we're going to make a field scoring rules. Yep, right where we are. We're going to make it read-only. Okay. So we now have a set of scoring rules that we create when you construct this. We could pass these in if we wanted to and make it so that when someone creates this, they do that. But again, not going to do it just yet because we don't have a reason. Hey, thanks for stopping by, Staker. Have a good one. Let's see. So we can now apply these scoring rules. So you'll notice they went in an order. So I'm going to say for each scoring rule, we can go ahead and say total score plus equals scoring rule, apply rule to the dice rolled, and we can get rid of all of this. And in theory, these tests still work. Cross your fingers, guys. Hey, still works. Okay. So what we've got now is we just define the set of rules that we're working with and just sort of let that go, which is kind of neat, to be honest. So we do have an order that matters here, and if it came down to it, we could set up these scoring rules with some kind of an ordinal, or some knowledge that they need to happen in some specific order. Other options are things like figuring out the value per die so that we don't do things out of order. So for example, triple ones is worth 1,000 points, which means that 333 points is the value per die on that one. So we want to apply that rule first if we can. That's one way of handling it. Clearly doesn't handle all scenarios that way, so either you have to hard code it in, where a programmer has to get involved, or you have to put some kind of brute force mechanism where it tries all the different applicable rules, say finds them first, and then determines the order best to apply them. So you could find all applicable rules and see if you can apply them. Something else we could have done here, talking about this, we did our single die scoring rule. Now I don't know what your thought on this one is, everybody, but we're removing every die out of this set when we do this, but we don't have to, because we could just make this do a single die, remove that one, and reapply the rule. So we could have this system set up so that it attempts to apply the rules every time it can. So instead of just going through each one of these, we then could say, like, while the scoring rule, is applicable, right? And we could just keep running it like that the whole time. So we have a lot of options for how we want to do this. Now, what this did here was this actually follows a couple of different things. This, first off, is giving us a little bit of power of open-close principle, in that we don't really have to come in here and do anything. We're just adding another item to the set. Now you could say, yeah, you modified it. But it's like, yeah, but what I don't have to do is I don't have to change these rules anymore. So you'll remember, in the beginning, when we wrote the triple ones and the triple fives, we had to subtract 150 or 300 for the fives and the ones, respectively, because of the fact that the single die rule existed. Whereas right now, if I came in and I said, hey, you know what, now threes are going to be worth 30, and we added that rule, it's fine, because we already, in our triple rule for the threes, handled that case. So it's actually pretty nice. We removed these already. So yeah, I'd call that pretty good. So a couple of things I'm thinking about for future things. I want to do a talk where we go ahead and write an IOC container together. Hopefully people will get involved for that one. The reason I want to write an IOC container is a lot of times when people talk about dependency injection and dependency inversion, which we're all doing, we all use IOC containers for that. Now, the reason I bring this up is, first off, in a lot of small solutions, so think like Docker and things like that, where we're making all these microservices, or just in any small scale stuff, I kind of feel like setting up an IOC container is a little bit overkill. So I a lot of times will just use what I call poor man's dependency injection, where I will just pass in the objects in a different way, because I don't really need the IOC container. My solution is so simple that adding it in is just adding complexity and configuration I don't want to deal with. But a lot of developers that I work with will bring up the idea that they almost look at the IOC container like it's some kind of mystical, magical thing that does these tasks for them. And I can tell you that it is magical. It is wonderful. IOC containers and version of control containers, or they're what help us in doing dependency inversion, dependency injection. We basically just tell them an object type we want, and they give us one. So think like service locator, that kind of thing. Or if you use structure map, whatever it is you use for your IOC container, that's basically what they are. A lot of people look at these as magical, and they really aren't. And the way that I usually teach people about how an IOC container works is the same thing that demystifies them a little bit. And that is, I just go ahead and write one. So literally, you guys can work with me and we'll make an IOC container in like 15-20 minutes. We can talk about it, we can mess around with it, we can add some complexity to it, things like dealing with the life cycle. So we might decide that we want the lifetime of our objects created by our IOC containers, say, to be request-based, or to make sure there's a singleton, we only have one for each type, and things like that. So we can add as much complexity to the IOC container as we want, but either way, it's a pretty simple approach, and you'll see how they work, taking a little bit of the magic away, and I think they'll be easier to work with. So anyway, our next DevChatter programming that we'll do is going to be on Monday, 2 p.m. Eastern Time. That's, what is that, like 7 p.m. UTC, something like that. Yeah. Anyway, hopefully everybody had fun, and you're looking forward to a good rest of your weekend. Hopefully you have something fun planned. I know I do. And I will catch you guys all on Monday. So happy coding, and take care.